Classification of lipids. Today's topic is classification of lipids. So these lipids have been classified into three groups. So these lipids have been classified into three groups. These groups are one of the group of lipids. Those are known as simple lipids. Second type of lipids, they are known as conjugated lipids. Third type of lipids, those are known as derived lipids. So lipids have been derived, where these divided into three classes: simple lipids, conjugated lipids, and derived lipids. We will take the first one, simple lipids. We will discuss about this first one. Those are simple lipids. What are these simple lipids? These simple lipids are the esters of fatty acids with various alcohols. So these simple lipids are esters of fatty acids with various alcohols. So that means esters, there is ester bond. That is why they are known as esters of fatty acid and alcohol. The ester bond is that bond which is formed between acid and alcohol. So definitely there is the ester bond which is formed between acid, that is fatty acid, and the alcohol. Such bonds are, these are covalent bonds, such bonds are known as ester bonds. Now these simple lipids are the esters of fatty acids with various alcohols. And these simple lipids are further of two types. These simple lipids are further of two types. One of them, true fats, which are also known as neutral fats. So first type of simple lipids, true fats or neutral fats. Second type, waxes. So these simple lipids, which are esters of fatty acids with various alcohols, they are of two types: true lipids, or these true fats or neutral fats, and second type, waxes. We will take the first one, true fats or neutral fats. These true fats are the esters of fatty acids with glycerol. So what are true fats or neutral fats? These are esters of fatty acid with glycerol. Glycerol is also alcohol, but low molecular weight alcohol. These neutral fats are also known as glycerides. So these are also known as glycerides. So these true fats, neutral fats, are also known as glycerides, and they are composed of esters of fatty acid with low molecular weight alcohol, that is glycerol. Now this neutral fat or this glyceride molecule, it consists of three components. It consists of two components, not three, two components. One are fatty acids. Fatty acids. Fatty acid is having general formula RCOH. This is fatty acid. That means it consists of hydrocarbon chain, that is represented by R, and carboxylic group, that is COH group. So this is the general formula of fatty acid. or COH. What is R? This R is hydrocarbon chain. Then second is glycerol. So these are neutral fats. They are composed of two components. One is fatty acid, general formula RCOH. Then second is glycerol. This glycerol molecule consists of 3 carbon atoms. And each carbon atom bears hydroxyl group, OH group. So there are 3 carbon atoms in a glycerol molecule. Each carbon atom bears hydroxyl group. These are hydrogen atoms for maintaining the valency. So this is the structure of glycerol. CH2, CH2OH, CHOH, CH2OH. It is the structure of glycerol. Now this neutral fat is composed of 2 components. One is glycerol, second are fatty acids. These fatty acids, there may be 1 to 3 fatty acids present in the neutral fats. So if there is 1 fatty acid and 1 glycerol, then they are known as monoglycerides. If there are 2 fatty acids and 1 glycerol, then they are known as diglycerides. If they contain 3 fatty acids and 1 glycerol, they are known as triglycerides. Generally, the animal fat is mainly triglyceride. That means 3 fatty acids. This is fatty acid, this is R, COOH, this is 1 fatty acid. Usually there are 3 fatty acids, mainly the animal fat. Animal fats are triglycerides. This is second fatty acid, RCOOH, this is third fatty acid. Fatty acid number 1, fatty acid number 2, fatty acid number 3. RCOH is fatty acid number 1, RCOH is fatty acid number 3, general formula of fatty acids. Then we will take here the glycerol molecule. This glycerol molecule is having formula CH2OH, CH2OH, then CHOH, this is CHOH, and then CH2OH. This is the glycerol. These are 3 fatty acids. So we will take here 3 fatty acids and 1 glycerol. What happens? There occurs condensation reaction. 3 water molecules are released. OH is released by the carboxylic group. H is provided by hydroxyl group of glycerol. Just see. 3 water molecules are eliminated here. Now, once 3 molecules are eliminated here, the remaining structure remains R1CO. Okay? Then there is bond, that is OCH2 bond. This bond is known as ester bond. This COOC bond, this bond, CO, this C is carbon is attached by double bond with oxygen, and this bond between carbon and oxygen, and this oxygen is attached with this carbon, this bond is known as ester bond, which is formed between the carbonyl group of fatty acid and hydroxyl group of glycerol. Then second fatty acid, R2CO, like this. Then this forms bond with oxygen of this glycerol molecule. This is CH, but there is bond between carbon and carbon. Then there is another R3CO. Then this forms bond with the oxygen molecule of glycerol. then this is CH2. There is bond between carbon and carbon. So this molecule formed here is known as triglyceride or neutral fat. Now this triglyceride or neutral fat, that is the animal fat, that mainly consists of 3 fatty acids and 1 carboxylic group. And there is formation of a bond that is known as ester bonds. So that is why lipids are known as esters of fatty acids. So what is ester bond? The bond which is formed between acid, that is the COH, and the glycerol molecule, alcohol molecule, that is known as ester bond. So this is the general formula of triglycerides. Now we will take the structure of animal fat, those fatty acids, those fats which are present in the animals. For example, I will take tripalmitin. This tripalmitin is a fat present in animals. So it is animal fat. This tripalmitin is made up of 3 palmitic acids, and you know that palmitic acid is a fatty acid. One palmitic acid, you know that, contains C15H31COH, molecular formula of palmitic acid, one palmitic acid. So tripalmitin is an animal fat that consists of 3 palmitic acids and 1 glycerol molecule. So what is tripalmitin? Tripalmitin is animal fat, and this tri means 3. It consists of 3 palmitic acids, 3 fatty acids, and 1 glycerol. And you know that palmitic acid is molecular formula of palmitic acid is C15H31COH, or you can also write down it CH3 methyl group, then methylene group CH2, that is 14 times. So 14 carbon and this CH3 methyl carbon is 15, and then COOH, expanded form of palmitin. Now we will take here 3 palmitic acids, CH3, CH2, 14 times. This is carboxylic group. This is 1 palmitin. This palmitic acid, sorry. Now we will take another palmitic acid, CH3, CH2, 14 times, then COH group. This is second palmitic acid, fatty acid. Then third, CH3, CH2, 14 times. This is carboxylic group. This is third palmitic acid. So these are 3 fatty acids known as palmitic acids. So these are 3 palmitic acids. Now we will take 1 glycerol molecule, and you know that glycerol molecule consists of 3 carbon atoms. Each carbon atom contains hydroxyl group, OH group. To maintain the valency, there are 2 hydrogen atoms on the carbon number first, 1 hydrogen atom carbon number second, and 2 hydrogen atoms to the carbon number third. This is the glycerol molecule. So here we are describing the structure of tripalmitin, which is an animal fat, and it is made up of 3 palmitic acids, 3 fatty acids, and 1 glycerol molecule. There is elimination of 3 water molecules, okay, hydroxyl group of carboxylic acid and hydrogen of the glycerol. 3 water molecules are eliminated. Now the remaining structure, that is CH3, CH2, 14 times, then CO group, carbonyl group, which forms bond with the oxygen of glycerol. Then second palmitic acid, CH3, CH2 14 times. Then there is a carbonyl group forming ester bond with the, I can say, oxygen of the glycerol molecule, and this is the carbon of glycerol molecule. This is hydrogen. This carbon is having the bond here, this bond. Then there is another palmitic acid, CH3, CH2 14 times, CO group, carbonyl group, forming bond with oxygen. This is carbon. These are two hydrogen atoms. There is another bond. So now this structure for molecule formed here is tripalmitin. So what is tripalmitin? It is the animal fat. It is the fat which is found in animals. Now this tripalmitin, it is mainly composed of 3 palmitic acids and 1 glycerol. Similarly, there is another fat present in the animals that is known as tricitidine. And this tricitidine, it consists of 3 fatty acids known as citric acids. 3 citric acids and 1 glycerol molecule. And you know that the citric acid, it is a molecular formula is C17H35COH, or you can write down it in an expanded form, CH3 methyl group, then CH2 methylene group. How many? That means 16 plus 1 17. These are 17 carbons. Then COOH. This is the structure of CT1 citric acid. So you have to take 3 citric acids and 1 glycerol molecule, and you can get tricitidine. So this was about the true fats or the neutral fats which are found mainly in the animals, and that is tripalmitin, which is found in animals, and tricitidine, as well as there are some these true fats with neutral fats are also found in plants. Lipids. Simple lipids are of 2 types. One are neutral fats, true fats. Second are waxes. So waxes are simple lipids. So what are these waxes? These waxes are esters of fatty acids. Esters of fatty acids with high molecular weight alcohol in a state of glycerol. Are you getting me? So what are waxes? These are also esters of fatty acids, but not with the glycerol, but with the high molecular weight alcohol. This is the main difference between the neutral fats and waxes. So neutral fats contain esters of fatty acid with glycerol, low molecular weight. But on the other hand, the waxes are also esters of fatty acids, but not with the glycerol, with high molecular weight alcohol. These waxes, they are chemically inert. They are chemically inert and are highly insoluble in water. Why waxes are chemically inert? Why they are highly insoluble in water? The reason is that because they contain no double bonds in the hydrocarbon chain. They contain no double bonds in the hydrocarbon chain of fatty acids. So that is why they are chemically inert. So they only contain single bonds in the hydrocarbon chain of fatty acids. And these waxes, for example, I will take one of the example of this wax which is naturally producing in this, I can say, on this universe, that is the bee wax. This bee wax, it is naturally produced by the abdominal glands of worker honeybee. Worker honeybee. So you know that the honeybees have three castes: queen, workers, and drones. Queen and workers are females. Queen is fertile female, but workers are sterile females. And drone is male, but that is haploid. It is the queen which is fertile, which lay the eggs, and the workers are sterile. They do not lay eggs. Only these workers, they are also females, but these are sterile females. They do not produce the eggs. However, they nourish the queen and the young ones and also build the hive. So this bee wax produced by the abdominal glands of worker honeybee, this bee wax is used for building beehive. So this beehive is mainly composed of bee wax, and this bee wax is formed by the esterification of palmitic acid. You know that palmitic acid is a fatty acid, and myricil alcohol. Myricil alcohol is high molecular weight alcohol. So I will take here the myricil alcohol, that is C30 molecular formula H61OH. This is myricil alcohol having the molecular formula C30 H61OH. High molecular weight alcohol, myricil alcohol. Now we will take the palmitic acid C15 H31 COH. This is palmitic acid, fatty acid. Now there is elimination of water molecule. This is the, I can say, hydrogen of glycerol molecule and OH, hydroxyl group of palmitic acid. They are eliminated and water molecule is released. Now the remaining compound, that is C30H61, this is oxygen, then there is the, I can say, this carbon, then oxygen, then C15H31. This is the bee wax, molecular formula of bee wax. C30 H61, then oxygen which forms bond with the carbon, CO group of, carbonyl group of these fatty acids, then C15 H31. This is the molecular formula of bee wax. This bee wax is used for making the hives. These waxes are also used for making polishes. They are also used for making the, I can say, cosmetics. Similarly, in some other animals such as sheep, they have cutaneous glands. These cutaneous glands are also second glands. These second glands produce a wax. That wax is known as lanolin. So this lanolin is a wax produced by cutaneous glands of the sheep, and this wax, this lanolin wax, it forms protein, water resistant covering on the animal part, on the fur of sheep. So this was about the second type of the simple lipids, that is waxes. So these were the simple lipids. One are neutral fats and second are waxes. Now the second group of lipids, one was the simple lipids, second conjugated lipids. These conjugated lipids, these are esters of fatty acids. These are esters of fatty acids with alcohol. These are esters of fatty acids with alcohol, but also contain some other substances. These are esters of fatty acids with alcohol, but they contain some other substances. And these conjugated lipids are represented by phospholipids. These phospholipids contain fatty acid, glycerol, and phosphate group. Other substances here, phosphate group. They include lipoproteins. That means they contain fatty acids, they contain glycerol, but they also contain other substances, protein. They also include glycolipids. That means they contain fatty acid, glycerol, fatty acids, and other substance is the carbohydrate. We will take here the structure of phospholipids. Very important biomolecule. This phospholipid molecule is made up of three components. One component that is two fatty acids. Besides that, one glycerol molecule, and they contain phosphate group. So phospholipid molecule is made up of two fatty acids, glycerol and phosphate group. Now we will take here the structure. This is the RCOH. This is one fatty acid. So fatty acid is made up of two components, R, that's hydrocarbon chain, and carboxylic group. Then second fatty acid, RCOOH. This is second fatty acid. Now third fatty acid is replaced by phosphate group. Phosphate group is usually H3PO4, phosphoric acid. So chemically it is known as phosphoric acid. That is, this is phosphate. It is attached with three hydroxyl groups like this, and on the fourth side there is oxygen having double bond. So this is H3PO4. But biologically it is called as phosphate group, PO4. Phosphate group, because it dissociates and releases the hydrogen atoms. It is known as phosphate group. So two fatty acids and one phosphate group or phosphoric acid. Then one molecule of glycerol, and glycerol contains three carbon atoms. Each carbon atom is attached with hydroxyl group, and there are two hydrogen atoms. There is one hydrogen atom, there are two hydrogen atoms. Now there occurs condensation reaction. Hydroxyl group of carboxylic acid, hydrogen of glycerol, like this. And finally what happens is three water molecules are eliminated. Now the remaining structure, that is R, C double bond O, then this carbon forms bond with oxygen, this is CH2. Then second R, C double bond O, this is oxygen, this forms bond with this oxygen, this is carbon, this is hydrogen. Okay. Then third, that is P double bond with here oxygen. Then OH, I will already write here hydrogen. Why? Because this oxygen, hydrogen ions are dissociated. Then there is the, I can say, bond with oxygen. This is carbon of glycerol. There is another bond. This is H2. Now this structure is known as phospholipid. This is the structure of phospholipid. Having two fatty acids, one phosphate group and one glycerol molecule. Now this mainly this phospholipid molecule, it consists of two parts. One is this phosphate group. This phosphate group, it is mainly polar. Why polar? Because there is bond between phosphorus and oxygen. That means there is bond between different electronegative atoms. There is bond between heteroatoms. That one is called as polar. So physically we can show that this phosphate group, it forms the head. If we take the physical structure here, this is the head. So this head is made up of phosphate group. This is phosphate group. And this head is polar. What is polar? Hydrophilic, water loving. Because water is itself polar. Polar dissolves in polar. Then there is this, I can say, glycerol molecule. This glycerol molecule forms the neck, and here also the bond is between the same carbon atoms, so it is non-polar. Then there are two fatty acids, one fatty acid and another. So then there are two, I can say, fatty acids. Tadpole-like. Why? Because they have non-polar bonds. So these fatty acids they are non-polar. Why? Because there is bond between same electronegative atoms, that is carbon-carbon. Because R is represented by hydrocarbon chain. There is bond between carbon and carbon, same atoms, same electronegative atoms, or I can say homoatoms. So now these tails, two tails, these tails are made up of two fatty acids, and these tails are non-polar, hydrophobic. Why hydrophobic? Because water hating. They are non-polar. There is bond between carbon and carbon. So these fatty acids are two, phosphate group is one. So this is the physical structure of phospholipid molecule. So now you know that phospholipid molecule is having head, which is polar, and two tails. Why two tails? Why not three tails, or why not one tail? Because there are two fatty acids. So that's why there are two tails. Now this phospholipid molecule, it is amphipathic. Why amphipathic molecule? Because it consists of both polar and non-polar parts. Polar part is made up of phosphate group, and the non-polar parts, tails, they are made up of hydrocarbon chain. Due to the amphipathic nature, these phospholipid molecules, once they kept on, these phospholipid molecules, once they are kept on the surface of water like this, they form two layers. Like this, they form two layers. The tails face each other, and the head are directed outwards and inwards. That means these phospholipid molecules, they form two layers. Head moves towards the water and tails face each other, because tails are non-polar. Non-polar dissolves in non-polar. These are, heads are polar, they move towards the water, and they form bilayer. This one is bilayer of phospholipids. This is known as bilayer of phospholipids. That is why these bilayer of phospholipids, they are biologically important, because they form the structure of biomembranes. What are biomembranes? Plasma membrane and the membranes of cell organelles are known as biomembranes. So all biomembranes are composed of bilayer of phospholipids. This is the cytoplasm of cell, and cytoplasm of cell contains water. So that is why this polar head is directed towards the water. And on the outside the cell there is ECF. What is ECF? Extracellular fluid. And that extracellular fluid also contains water. That is why the head of this molecule moves towards the water, and they form bilayer like this. They form bilayer of lipids. So this bilayer of lipids, it forms a water resistant barrier. That means water cannot enter through this phosphobilipid layer into the cell. That is why there are tunnel proteins. These tunnel proteins, they have the pores through which that water can enter. Now you know that these phospholipids, they form the structure of biomembranes. And these phospholipids which are present here, the tails of these phospholipid molecules in the biomembranes, those are mainly unsaturated. One thing you should remember here, mainly the fatty acids present in the phospholipid molecule in biomembranes are unsaturated fatty acids. And you know that unsaturated fatty acids are liquid at room temperature. So that means these fatty acids are then oil. So we can say this is the cell. This cell is surrounded by plasma membrane. What is this plasma membrane? Actually, this is the oil, because the fatty acids are unsaturated. So this was all about the